Where we're going to talk about how to kind of get some of these technologies out of the lab to kind of go back to this question of building up an industry sort of from scratch. I'm going to just very briefly introduce the panelists, not going to go into too much detail. All of the further information is just a Google away, so just in the interest of kind of getting straight into it. We've met Freeke earlier, and next to her is Mike Biercuk from the University of Sydney, and Dave Moehring, the CEO of IonQ, Ilyas, the CEO of Cambridge Quantum Computing, and Simon Benjamin from the University of Oxford, who also works with the UK's Networked Quantum Information Technologies Group, part of the sort of national effort there. So there are a couple of things. I'm going to indulge my personal interest here, at least in part, but I know I've kind of spoken with each of you to kind of get a sense of what your greatest concerns are and what you think the sort of the biggest things in terms of answering this question of how do we get this stuff out of the lab. And there's certainly a diversity of profession here, and so thereby a diversity of opinion. But one thing that has come up repeatedly among us, but I know hasn't come up today and I think is actually very fundamental to this question, is about hype. We have, there is all of this tremendous interest. There is all of this funding. There is so much goodwill. People are interested. They want to know more. But the industry as a whole is at risk, perhaps as artificial intelligence was more than once, of overpromising or kind of just overcooking it early in the game. And we are very much still early in the game here. So let me kind of take these one person at a time. Ilyas, I know you've mentioned a concern about hype. And yet you're from the sort of the startup side of things. How do you balance it? How do you view the risk of hype and indeed the benefits of some hype?
Well, I think the word hype itself carries baggage. I prefer your comment about over-promising and under-delivering. So,
as you wish.
I think that this morning, for example, prior to this session, there was a meeting over at Google, really at Google's insistence, which I think is perhaps a good example of why some of those dangers will diverge. And the variance that we perhaps have seen over the last 2 years might begin to blur, and hopefully there'll be some consensus. And in that meeting were 4 startups and Google, and one of the topics, some of my colleagues were there this morning, some of the topics that we talked about when asked by Google what's important to you, in return we said, well, a standardization of the roadmap, of definitions, of use of language, and the qualifications that go with it, so that if we, who nobody listens to because nobody's heard of Cambridge Quantum, can then be referred to a Google comment on this, then that will certainly help. So I think that from my standpoint, a continuation of that, including this wonderful day that we've had already, will be a tangible step away from that, so that the corporates who are customers for all of us are the recipients of the same message.
I hesitate to use the phrase thought leadership, but you're calling for some.
Yes, okay. I'm not ashamed of pleading for thought leadership. I guess what changes is when you have a commercial contract. So in our firm, we have now commercial contracts where we're expected to deliver in return for payment some product which is quantum linked. It might be a quantum technology or it might be related to quantum computing. In fact, Simon and his group are one of our customers by extension, because we're building and helping design one of the modules for the compiler for the machine that they're building. That makes us better equipped to then relay back to the community what we think is happening in terms of timelines. So that helps.
That's easily thrown to you then, Simon, because I know that hype is something that kind of a bugbear for you as well.
Yeah, that's right. So I am actually very worried about hype. I've been worried about hype since before we had this present kind of real interest in quantum computing from the industry side. I think the field has a problem, which is that it's quite hard for people to explain to non-specialists what the heck we're all doing. And as a result of that, when people put out press releases or short stories about scientific advances, it tends to default through to just a lot of language about how these machines are amazing and they're going to be much faster than a conventional computer built with all the atoms in the universe and this kind of thing. And there's only so many times that you can get people excited. I've already seen on websites where people have been commenting on these kind of stories, a kind of hype fatigue. So, and that's before industry comes in. So we have a lot of startups and so on, and that's fantastic. But the problem is that startups, need to create a certain energy to maintain investment, which leads to more hype. And a particular phrase that I absolutely hate is quantum supremacy, because it sounds like when you reach quantum supremacy, there's no point in having anything except a quantum computer, right? I mean, it's clearly the quantum computer is supreme. So throw away your laptop and your iPhone, and when we reach quantum supremacy, to be clear, it won't be good for anything, okay, except making science and nature papers for the academics. Quantum supremacy is not the point at which quantum computers become useful. It's simply the point at which they can't be simulated by conventional computers. So inimitable would be the word. It's quantum inimitability, which is a lot less catchy. But, that's what's actually going to happen. And the problem is that when quantum supremacy comes, and it is a big deal, it's a big milestone, but that's just one more thing that sounds like it's arrived now. And when we find we can't actually do anything with the quantum supreme machine as it is, that's dangerous for the field. It gives us the risk that we will kind of implode, I feel.
In talking about the sort of this milestone being set up of quantum supremacy and what it'll be good for, I think another thing that has come up a lot and that hasn't been talked about yet much today is about the sort of near-term applications, kind of aligning the timescales and the scope of both the supply and demand. Freeke, you must have thought a lot about kind of trying to align those two things and what the nearer term, because it's easy enough to say, here's what we'll get in 20 years and it's going to be amazing. What are your thoughts on how to convey and how to sort of convey the excitement of what happens much closer?
I think there are two things. I think it's important to also tell the story that we just do not know exactly what is going to happen in the future, because that's not a strange story to tell to the public. And if you look back in history, you can easily say there have been technologies that were so impactful, that weren't foreseen, but were very, so it's worth investing in basic research and in R&D. Instead of trying to promise things like, oh, we're gonna have a new molecule in 2 years or something, because I think that's risky, because then you get into ice and you don't know, On the other hand, of course, you can't say, oh, in the future there's a rainbow and there's gonna be gold. So, of course, we think about first applications, and I think what's very important is to, bring these first small demonstrators to the public and to application builders so that they can also help answer that question. For instance, what IBM is doing, and so really have the larger community work on the demonstrators to think about that. And well, I think quantum chemistry, so that's, I think the field is a bit like converging on that thing.
And from let me bring you in, Dave, from the sort of hardware side of that, I know you've kind of mentioned about that nearer term apps and what sort of means of selling it but not overselling it. What are your thoughts on how to define and then convey nearer term apps?
So I mean, not just from IonQ, but you heard it from Rigetti and IBM. I mean, identifying the near term app is one of the most important things that we can do right now. I mean, we're obviously all working on different hardware platforms to get there, but I mean, fundamentally, this is like one of the best definitions I can think of disruptive technology. And as is true of any disruptive technology, it's by definition, it's impossible to understand where the first applications are going to be. No,
but you still have to, I mean, if you want people to sort of buy into it, you still have to come up with you have to sell some story of some kind. I mean, how do you navigate that?
I mean, it depends who you're trying to sell it to. So I used to work for the federal government in the United States, and the sales can be very long-term because the federal government, by definition, is not in the business of making money. If you're talking to venture capitalists that have a demand on a return on investment of 3 years, you had better come up with a story that's 3 years. There are those who are willing to make long-term investments because they understand that quantum computing is not going to go away. Moore's law is going away, And quantum computing is one way of overcoming our never-ending hunger for solving very hard problems. So you can't take only a short-term view of this. Sure, I'm very excited about whatever the hearing aid is going to be as the transistor for classical computing. What is that for quantum computing? I don't know. And if you have the right investors and the right backers, then you also don't even have to answer that question. You have to make, at the end of the day, it really comes down to the hardware.
Did you want to add to that, Ilyas?
No, I was nodding politely.
At the mention of VCs and timelines, Mike, I know that one of the things that you were thinking about is kind of the inevitable culture clash that comes here, and again we talked about how this is sort of intimately involved with academia in a way that we kind of haven't really seen certainly in recent memory. What about kind of trying to align the various expected timelines, desires, predilections of academics versus the funders?
I mean, it's a big challenge, and let me say at the outset, I'm extraordinarily bullish about this technology, even though I am representing the academic side. My view is that quantum technology, which harnesses quantum coherent phenomena as resources, will be in the 21st century as impactful as harnessing electricity was in the 19th. I truly believe that, but in this phase of development in the field, I think one of the most important things is managing expectations. We heard a little bit about timelines in VC before. What we haven't talked a lot about today, we've talked about software, we've talked about the application stack, we've talked about is it open source or not. We haven't talked about the fact that the fundamental challenges still need to be overcome. The entry into the field of startups, say, has not fundamentally changed the hard problems that need to be solved. And almost all of those are at the physical layer. They're all at the layer of the physical devices in which we encode and process quantum information or do some other useful thing with them. And so with this in mind, I think we really need to keep abreast of the situation that this is a deep tech hardware development effort. And that means that if people are promising 3 months to a quantum computing application, well, when that doesn't materialize in 2 years, it's going to be bad for everybody. So my personal view on this is that we benefit by having more engagement between the startup venture capital culture and the academic sector, because as David was, I also used to work for the federal government in the United States. I worked at DARPA when I was helping to oversee investments in this space. And we learned a lot about how we can make these two sectors work together and what throwing capital at the problem can and cannot do. And so I think the key aspect is we still need creativity. Creativity is fundamental to solving the big challenging problems that remain outstanding in the field. And the drivers and the incentives are different for people who are selling a company or selling a product and people who kind of enjoy intellectual curiosities, right? The partnership is what I think we need to foster in order to actually make this really happen.
Yeah, but there are still going to be some things that sort of interrupt that easily described happy relationship there.
I didn't say is necessarily happy at the start. I mean, I think my point is this is a hardware problem, right? We talk about, technology development in the context of all we've seen in the past 15 or 20 years in software development, and we forget that all of that software runs on hardware that was built over many, many decades and saw incremental progress to the point that many of the pieces of hardware we use are completely commoditized. You sell DRAM for 5 cents a chip or something, right? We need to change the culture to embrace the fact that this kind of technology development is a little bit different. We benefit from VC, we benefit from large-scale industry, and we also benefit from academics.
To get away a little bit, I'll keep kind of pushing this point that it's, as much as it's software and hardware questions, they're also kind of wetware questions, right? Another one that comes up in how this stuff is going to be developed is around intellectual property, right? There's very opposing directions for academics versus VCs. Academics want to tell their community as soon as they find something, they want to have the sort of professional capital of getting peer-reviewed publications and so on. That's going to run really hard up against the desire to kind of keep stuff under wraps. And I know, Simon, that's something that you're worried about as well.
Yeah, I think it's the thing that any academic who starts to work with companies, which I've done and enjoyed doing, really needs to think about is you're trying to come up with ideas, and these are early stage ideas, which could potentially, if you're lucky enough to have a really important idea, could potentially be enabling for an entire kind of sector. is it the best possible thing if that then becomes locked up and becomes the property, essentially, of a company, which may, ideally, it would seek to exploit it strongly, but it's even possible that a company might find it more strategic to just sit on that idea for a while. So I think that some of the early progress in the field has been driven by the fact that there wasn't really IP protection around a number of key ideas. And that's one of the things I think that we need to think about as we're going forward. And it's a kind of a thought which is perhaps not one that academics who haven't previously worked with industry, you just see it as an annoying thing that needs to get sorted out by the contracts people. But if you don't watch it, you're actually going to find that your ideas are not freely usable by other people, which is, I guess, the reason a lot of people went into academia, is to do that kind of research.
Yeah. Ilyas, do you have any thoughts on that?
Well, perhaps just to share a slightly complementary perspective. I mean, we've been around for 3 years now when we came out of the university. And what has happened, at least in our case, is that on the one hand, we have benefited from the sophisticated development of rules around the engagement of IP. And in 2 cases, patents that we've obtained, we've granted the academic inventor with an actual equity share rather than some phony baloney sort of interest. And obviously the motivation there means that at least there's alignment of interest in principle. And at the same time, we do have on staff people that are actually employed at the university, so we pay the development office and then we obtain ours, and those obviously are governed by IP rules that have been thought out. They may or may not be in the future. They may be proven that there's a better way of doing it, but at the moment we've certainly benefited from being able to do that. Still early days, and I think that the points that have been made by these chaps clearly resonate with me, but from a purely practical standpoint, being able to commercialize, as I said earlier, we now have contracts, so we're commercial, we're no longer just R&D. That would not have happened had we not motivated our academic partners with genuine ownership of the fruits of their labor. In one case, he's sitting over there, I think he's been in the business for 20 years, Simone. 19 years and 364 days of which nobody's ever... So I think that's perhaps one of the ways in which it might work.
Sure.
Yeah,
just
sorry,
real quick. Dave, you had a thought?
Yeah, I just wanted to add that, so I'm excited, whether you call it hype or overpromising or whatever you call it. It's important for this part of this development to leave, just the, sub-basements of physics buildings. Because within that sort of setting, the primary motivation of an academic research group is education, publishing, and what is very difficult is systems engineering, bringing a lot of different disciplines together to build a larger machine. And it would have been too early to have had this sort of spin out into industry, be it startup or large company, 10 years ago. We are at the point now where it makes sense to do that on a lot of different technology platforms. If there's a piece of the hype that I'm concerned about is that government stop funding the fundamental research side of it, because as Mike said, and as Simon said, and everybody who just nodded their head understands, is that there's still a bunch of fundamental research that needs to take place. There's still a lot of publishing that needs to happen. There's a new set of engineering research that's taking place within the quantum computing community, but that should not come instead of fundamental research.
Sure. And Simon, you wanted to weigh in?
Yeah, I think that's largely said it. I guess there's 2 senses on the IP. One, of course, is making sure that the people who invent it get properly recognized for that. So there's that point. But that wasn't really my concern. My concern was more that in a world where the research is being driven by governments, usually with not too many strings attached, right? You win your grant, and then you do your best research, and as long as it gets, well recognized, you can have another grant, okay? So in that world, the discoveries that are made are there for everyone. You can put a company around exploiting an idea, as D-Wave did, for example, that was produced by academics and just put into the literature. As we transition to a world where a lot of even the foundational research, not just the engineering, which is enormously challenging, is being supported or co-supported by companies, we need to make sure that there isn't some great idea that everybody would love to run with that's actually locked up by some particular company that may or may not even choose to exploit it. So if I have a great idea for building a quantum computer and I say, give me some money, or from whatever source, I want to create this machine, and then the investor says, well, what's it going to do? And I say, it's going to do this, but by the way, someone else has the IP for that, then that takes away the motivation for that entire area. So this is just something to be cautious of, that's all.
So I would agree, sorry, very quickly with Simon, that I think the only real risk on the IP side is patent trolls, right? It's people that lock up patents and IP for, I don't know, for fun or for profit. But I actually don't think that there's very much harm in academics just effectively giving away their IP. I think it works pretty well, and for the most part, the partnerships can be enabled that way.
Now, Freeke, you exist at the nexus of all of this stuff, so what do you think about this?
Yeah, well, I totally agree, because what you see happening, for instance, with the partnerships with Intel and Microsoft, that these academics, of course, they want to publish. And so this is one key element of your contract or your collaboration. So, and also these companies would like to see happening, for instance, I know we were visiting IBM and they were saying, oh, we have this many Nobel laureates in the company, so also they want to, publish. If it's about a patent, mostly you don't publish about the details and the nitty-gritty of how you arrange your electronics in the experiment, but you publish about the results. And the patent goes on, the recipe.
You keep the crown jewels safe.
Something like that. And of course, it's a game to be played, but I think I'm not that worried about it.
Right, thank you for that. I think I wanted to save a bunch of time for questions, because I do think there's a lot of issues here that we need to kind of chat through, and I've had my time, really. So any questions from the audience? Are you going to stick me with asking the rest of the questions? Because I've got plenty. Hang on, one sec. One sec.
What are some things that you think academia can do to help on the education side, to help produce a workforce of people who can really do quantum engineering?
Thanks for prompting that. I guess we were all derelict in talking about it.
I was going to ask it next.
So I think, we talk about an ecosystem because it's a sexy buzzword, but I do think it needs to be discussed, because we need technically trained people. As we all said, this remains a deep tech, hardware-based initiative. We need people who understand all aspects of that, obviously who understand coding as well. And a big part of our mission, of course, is to provide a technically trained workforce, if you will, from people who are semiconductor engineers and can work in clean rooms and fabs, to people who simply understand what it's like to run experiments on quantum hardware, right? It's a very challenging enterprise. I think there's a lot of opportunity for that. I also think there's opportunity for better engagement of student placement, to say that this idea of exchange and better coupling of the industrial and the academic sector, it's easily facilitated if students are the focus of that.
Anyone else want to weigh in on that, or indeed kind of worries about staffing kind of further down the line? Yeah,
if I can just narrow it down to one particular aspect within academia, it'd be the computer science world. So I mean, as somebody who's hiring, hardware engineers that are not quantum trained, they don't all need to be quantum trained. I mean, obviously there's a co-design that has to go from top to bottom, and they have to understand what aspects of what they do in their traditional world and how it may or may not affect in like an unexpected way the quantum world. But it goes back to the early applications. Getting the computer scientists and understanding the languages. Who mentioned earlier who's going to be the woman who writes the first quantum computer programming language that's adopted by everybody. Not that COBOL was adopted by everybody, but that helps define and helps nurture the application space. So that's one very particular space that I would like to see.
Just going back to the question, so for 3 years now, and this will be the 4th year, we've taken I think in aggregate about 30 summer research fellowships from a variety of universities. We pay them as opposed to think of them as slave labor. 6 of them have come on board. Each one of them is governed with the ability for the research fellow to publish exactly what he or she wishes to publish. And in fact, the collaboration we've got with NQIT will be open sourced. So this issue of technology being locked away in some basement, it didn't occur to us. Now, perhaps that's because of where we came out of, but I think the question, I think, was what could we do more? I think the heads of research, people who were focused on their own personal areas of research, perhaps embrace the fact that smaller companies can actually be a nice place for some of their good students to spend their summer breaks rather than by default assuming that they should do internships at IBM or Microsoft or somewhere like, not that they're bad places. So I would just add that as the ecosystem develops over the course of the next few years.
Studentships being offered from the stage. Easy now.
So one more quick comment on that, Will. I think we've talked a lot about applications that really are at the absolute top level. We're talking about companies associated with building quantum computers or running quantum computers, and occasionally the middlemen who sell that software as a service. For students, I think we can really harness the creativity that comes from young students sometimes uninitiated in how crappy life can be in technology development, who come up with ideas that solve these fundamental hardware problems that I was talking about. I mean, an example that I like touches on my research, which is about bringing control theory to quantum systems to make them more useful. If you go onto like free patents online and you search for DRAM refresh, the kind of software-based technique that makes DRAM stable for your computer, there's 89,000 patents on DRAM refresh. And I think there's an opportunity for a whole ecosystem, again, to develop leveraging some of the creative, kind of longer range physical layer problems that are being addressed in academic labs and potentially turning them into software-ish companies in the future.
So this is another hardware-related question. So to characterize or to make a caricature of experimental research in quantum hardware, you take students that are trained in quantum physics, you bring them into a lab and you get them to do microwave electronics or write code or do various cryogenic wiring. And then each of these different labs around the world does their own non-optimal version of this. And then after 3 years, you fire your whole lab and get new people in. So, you know, some people might say that's not the most effective way to develop hardware, though it's obviously very effective in academic research. The question would be, you know, to what extent now, given the critical mass that we have in hardware, can we try to streamline that and make use of academic industry partnerships to address some of these engineering problems? And perhaps this also relates to the shovels for the gold age comment that was made earlier.
Yeah, I think that goes back to the comment I made earlier that what you just said, they don't get fired, they graduate and they move on. But that's precisely, yeah, some of them graduate and move on. Some of them just move on. But that's precisely why a lot of this hard engineering, and when I talked about the good side of the hype, if it is hype, we obviously think it's for real, is that you can now get permanent staff. You can get dedicated people. You don't want a physicist to write code. You want a coder to write code. You don't want a physicist to design an electronics board. You want somebody who's trained in doing that. Obviously, they can't just do that when you're doing a co-designed, you know, very hardware-intensive problem. They have to bleed into different disciplines. But this is precisely what you can do within a company that is very hard to do within a university setting. But you still need to hire new people. So that sort of collaboration, I mean, so we're, I think one of the reasons I was asked to be on this panel is we're a spin-out company from 2 different universities. So obviously we have very close ties with both of those universities. And that's important for the development of our company.
But I think it's important to remember that, you know, academics play a different role than systems engineers, right? And so, you know, directly to your point and to what Dave was just saying, it's very attractive to overcome this fundamental challenge we have in universities that you are aware of. We're really not able to hire permanent engineers. It's not permitted by grant rules. The universities don't allow it. And so having a relationship with startups that do hire, or more established companies that do hire this, having them embedded one way or the other, that's a very attractive proposition. It allows the academics to focus on these fundamental problems without trying to pretend they're going to build a quantum computer in a university research lab. It's just not going to happen.
Let's see, in the 24 seconds that we have left, if we can get away from the HR concerns for one real quick one. Who's got a quick one that's not around this sort of the staffing issue, which I recognize is gnarly? One here?
Well, it's not really short, and it's a little bit provocative. So bridging this gap, so academia is supposed to do more or less blue sky research, and companies is worried into real world applications. But don't you think that big companies like Google and IBM are just rich enough to afford blue sky research? Like AT&T was doing 40 years ago, for instance. I worked there in Bell Labs. You remember that? We were doing cold atoms in a telecom company.
So what, you think that nothing, no help is needed? This is already underway. We don't need to torture ourselves here on stage working out how to do it.
No,
You think
I
it's
think
being
the gap may be filled the other way. That is, these companies, in some sense, are bridging the gap by doing also this kind of, and so it's sort of an exchange in the roles. So I just wanted to know whether you have comments on.
So can I give a quick comment? Sure. I think that would be ideal if it worked like that, and obviously the oligopolies in defense and telecom from the 70s and 80s did facilitate that kind of basic research, but you know, the culture of a lot of these big companies, even though they have the same money, is not like that. Google is looking to divest from Boston Dynamics, probably the most exciting robotics company ever developed. The internal memos that have been leaked, I mean, I don't have any insider knowledge, I just know it's published in Wired, right? The memos suggest that they're not satisfied with a 10-year time horizon to revenue. So if that's the culture of these organizations, it's a very big problem.
I think you are right in one respect. So I think these companies do invest in very long-term research. So in a way, it is basic research, but the way they manage it and fund it, it's completely different. So it's not academic research. It's you know, it's a project. They really know how to lead a mission-driven research program. So it's a little bit of both, I would say.
The gap is not entirely bridged, which is in part why we're here, I suppose. Ironically, we ran over on time on my session, which is really embarrassing. But let me thank all the panelists for great discussion.